Okay, we're recording. So we are still in day 4. We're continuing this on. Talk about some special cases. Alright, so our first special case is something that looks like this. Y equals x squared minus 16. Okay, let's talk about this. Based on all your parent graphs, what are we thinking about this one? Based on all our parent graphs, what are we thinking? Matt?
Shooting star.
Shooting star, exactly. So this is definitely a shooting star. But now I'm going to cycle back in domain here. Okay. So if we were talking about the domain, all the x values for this, there would be a restriction. What would be the restriction for the domain of this one? What would be the restriction?
It'd be greater than 0.
Good. It has to be greater than 0. Could it be equal to 0? Yeah, we could have a 0 under here, right? So what we want to do is we want to take this x squared minus 16 and know that we need it to be greater than or equal to 0. This is talking about our domain of this graph. Hey, what else do I really hope you remember? I have a quadratic and an inequality. When you have a quadratic and an inequality, Nico, what do we have to do? What?
Dots.
We are going to have to do dots, but further down, after you do dots. Whenever you have a quadratic and an inequality, we have to do some kind of problem solving. Janine? Test the regions, exactly. So we're going to have to test the regions here. But first we're going to do what Nico said, and we are going to factor this into a dots. So we have x plus 4, x minus 4. Now it's not really about solving this factoring. We do use those numbers as reference numbers. Do we all agree 4 and negative 4 are our reference numbers here? So now I'm going to go ahead and I'm going to test my regions. So I'm going to take x is less than or equal to negative 4. Negative 4 is less than or equal to x, which is less than or equal to 4. And x is greater than or equal to 4. Now, when I test, do I want my product to be positive or negative? When I test, do I want it to be positive or negative? Positive. We need it to be positive. Why is it going to be positive? Because we want this to be greater than 0. If it's greater than 0, that's positive. Greater than or equal to 0 is positive. So now I'm going to pick a number that's less than negative 4. What's a number less than negative 4? Negative 5, perfect. So now I'm going to substitute in negative 5. Negative 5 plus 4, isn't that a negative? And then negative 5 minus 4, isn't that also another negative? What's a negative times a negative? Positive. So guess what? This is a winner. And what else is going to be a winner? The last one. The middle one will not work. Okay, so what is this telling us for our graph? It's telling us that we know this is going to be a shooting star. But it's going to be more than one shooting star based on our domain. So based on our domain, we have x is less than or equal to negative 4. So let's say this is 1, this is 2, this is 3, this is 4. 1, 2, 3, 4. So if we're less than or equal to negative 4, what I'm going to do is I'm going to start at negative 4, and then I'm going to do a shooting star going in the negative direction. But isn't there another part of this domain? X is less than or equal to negative 4, or what else? Greater than 4. So now I'm going to go to 4, and now I'm doing a shooting star in that area. So what is this my special case about? This is a shooting star, but how many shooting stars? 2 shooting stars. anytime you have x squared or a quadratic, it's going to be shooting stars going into two different regions. I'll write this out for you.
I found this on the web.
Oh, thank you. Okay, so now our domain is exactly what we found, x such that x is less than or equal to -4 or x is greater than or equal to 4. If I wanted to write this in interval notation, this would be square bracket, oh, not square bracket, sorry, parenthesis, -infinity, comma, -4 square bracket, or square bracket 4, comma, infinity, parenthesis.
Isn't the U also?
Yeah, an or is also a U. Absolutely, that's a union, is an or, yes.
Can you explain how you knew it was a special case?
Okay, so I knew this was a special case because normally when it's just a normal shooting star, just one shooting star, it's like y equals the square root of just x to the degree of 1.
The two that made it.
Yep, because now we've stepped this up to a quadratic with a shooting star and an exponent of 2. Now it's a special case where we're going to have shooting stars going in different directions. And I'm going to write that out for you now. So let's write this out. Star. All right, y equals the square root of x squared, ... meaning there's more with the x squared, right? Some kinds of quadratic. It's going to be a shooting star, or it's going to be two shooting stars in opposite directions. So I'll just say x squared minus a number. Hey, but now I'm going to flip this. Ready? So we're still in our special case. So now when we have x squared minus a number, blah, 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 we're shooting stars in opposite directions, right? Now let's look at this one. This was special case 1, special case 2. Let's say I have y equals the square root of 16 minus x squared. This is actually going to be different. How does it visually this look different?
Just swap places, x and
Yeah, so before you were taking 16 away from x squared, now you're taking x squared away from 16. It actually makes a difference. So now let's find the domain of this one. So we still want that restriction where 16, could we stop slamming our pen? Thank you. We still want the restriction of 16 minus x squared to be greater than or equal to 0 because you can't have a negative underneath a radical. And now again, I have a quadratic and an inequality, so I'm going to have to test the regions. Before I test the regions, we need to factor. So this is going to be 4 plus x, 4 minus x, greater than or equal to 0. My two reference numbers are still 4 and -4. So we're going to have x is less than or equal to -4. -4 is less than or equal to x, which is less than or equal to 4. And x is greater than or equal to 4. All right, let's pick a number that's less than -4. Let's go with -5. I'm going to plug in. What's 4 plus -5? Isn't that a negative number? Now, what's 4 minus -5? Isn't that a positive number? A negative times a positive is a negative. Well, I need greater than or equal to 0. So I need a positive outcome. This is negative. So what does that mean for us? That means this is out, which means what else is out? The last one. Let's test the middle. I'm going to pick 0. 4 plus 0 is positive. 4 minus 0 is positive. A positive times a positive is a positive. That is our winner. So now think about domain. I'm now saying my interval is between -4 and +4. If I'm between -4 and +4, are my shooting stars going in different directions or are they going towards each other? They're going towards each other. So let's look at our number line here. Our graph. Nico?
Does it really? So it matters like which of the regions like are accurate?
It does matter. Okay, so here we are again 1, 2, 3, 4. 1, 2, 3, 4. So now based on our domain, I'll write our domain up here. Based on our domain, we have x such that -4 is less than or equal to x, which is less than or equal to 4. That's saying my domain is between -4 and +4. If we were to write it into interval notation, it'd be square bracket -4, comma, +4 square bracket. So I'm at -4 and I'm at +4. And now what's happening is these shooting stars are going towards each other. The shooting stars are going towards each other. And we can't go towards each other and past each other. How come I can't go towards each other then past each other? How come this is wrong? Anybody know? Only 2 people?
The point is that it can't go past like -4 or +4.
Good. That's the whole point of the domain, right? It's telling you if I go past a -4, if I go past +4, it's going to make a solution that's not a real number. That won't work for us. So how does this look? This looks like 2 shooting stars that are coming and meeting, just like that. All right, so let's put a star here. So our second special case was when we have a number minus x squared. And that's going to be 2 shooting stars toward each other, making a semicircle. Stefano, are you taking notes? You are? How?
On my phone, I actually can't.
But I don't see you writing.
I will.
Oh, okay.
I have a notebook.
No, I don't see you writing on your screen.
Oh, no, my touchscreen doesn't work.
So you have to type everything? So what about the graphs?
The graphs, I just look at it.
So that's not going to really help you. It's up to you.
It's got a graph notebook. It's not
Okay.
better than using it.
That's probably better to use. So then you could have everything. Okay, let's keep going. What do we think this is going to be? Y equals the square root of x squared minus x minus 42. Do we agree shooting star? Do we agree shooting star? Yes. So now our options, what kind of shooting star? Are we shooting star opposite directions? Are we shooting star towards each other? What are we thinking? Ion, what are you thinking? Not thinking anything? You have to have a thought. Yeah, they're going away from each other. Why? Good, because the x squared's positive. When they're going towards each other, isn't it minus x squared? So when x squared is positive, they're going up away from each other. When they're going toward each other, it's negative x squared. When they're going away from each other, it's positive x squared. So let's go ahead. Do we still have to find the domain here? Yeah, we still have to find the domain. So how am I going to find the domain? Erin? Factor. So we want x squared minus x minus 42 to be what? Kim, to be what? We want x squared minus x minus 42 to be what? So we're finding the domain. So what do we do with this? X squared minus x minus 42. What do we do with it? I'm sorry? So you're factoring it, but I need to finish the, top part of this. What is x squared minus x minus 42? Does it have to equal 0? Does it have to be less than 0? Can it be greater than 0? What is it? What's the rest of this? We're trying to find the domain. It's greater than or equal to 0. Why? Why is it greater than or equal to 0? Tice, why is it greater than or equal to 0?
Because it's in the
Radical, good, because it's in the radical, and we can't have a negative number in a radical because then that's an imaginary number. That's why. So now let's factor. We're x minus 7, x plus 6, greater than or equal to 0. We set up to test our regions. We're going to test x is less than or equal to negative 6. Negative 6 is less than or equal to x, which is less than or equal to 7. And x is greater than or equal to 7. All right, first number I'm going to test is less than negative 6. I will use negative 7. Negative 7 minus 7, do we all agree that's a negative 14, so that's negative? And then negative 7 plus 6, that's a negative 1. Negative 1, negative times a negative is a positive. So if the first region works, what else is going to work? And what's not going to work? The middle one is out. So now this is going to help us graph. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 7. Okay, so my domain is saying I need x is less than or equal to negative 6. What am I going to do with that here? We know these are shooting stars. What am I doing with this? X is less than or equal to negative 6. Behind Ion, is it Luke? Yeah, Luke, tell me. For x is less than or equal to negative 6, how am I going to graph that?
you put a dot on negative 6 and 7, and then they shoot away from each other.
Perfect. They shoot away from each other. I didn't do negative 6. I did negative 7. Let me fix that. Sorry. Why didn't you catch me? There we go. They shoot away from each other. What did we not talk about? We didn't talk about the range here. Let's talk about the range. Yep. What is the range? Erin?
Y is greater than or equal to 0.
Yeah, y is greater than or equal to 0. Why?
Because it doesn't go lower than 0 and then it goes up for infinity.
Good. Look at our graph. What's the lowest point of our graph? Isn't it these dots right here, which are both equal at y equals 0? And then look at the highest points. Well, this one's an arrow forever, and this one's an arrow forever. An arrow forever means up forever. So that's why we're greater than or equal to 0. Interval notation would be 0 square bracket, comma, infinity, parenthesis. Okay, the last thing I need to show you. Now what we're going to do is we're going to graph absolute values of different functions. So not just v's. So graphing absolute value of different functions. So what I'm going to do is I'm going to do a sample problem, but along doing the sample problem, I'm going to write out the steps that we're going to do. So the problem I want us to sketch is y equals the absolute value of x squared minus 4. First thing, I know this isn't a v. How do I know this isn't a v? Because if it were a v, what degree would this exponent be? Oh no, 3 is the disco dancer. 1, exactly. If this were a v, this x would have a degree of 1. So I know for certain this is not a v. Since I know this is not a v, this is saying graph what's inside of here, whatever this is, then take the absolute value of it on the graph. Well, how do we do that? One step at a time. So we're going to graph what's inside the absolute value lines. Graph what's inside the absolute value lines. So if I'm graphing what's inside, what's x squared minus 4 out of all our parent functions? What is it? Nico? It's a parabola. I'm shifting this parabola. Where am I shifting this parabola? Matt? Be careful. If it were right 4, then it would have to be inside the x with the x, like x minus 4 squared. No, then that would be plus if it were left. So remember the format for translations was x minus h squared plus k. So that 4, it's not an h. What is it? K. That 4 is a k. It's not an h. How do I know it's not an h? Because the h would be grouped with the x.
Is that an important equation to memorize, or are we going to have that with us like on the quiz?
I'm not going to give it to you. So I think you should know it, since it's like, that's basically the translation if you just, for all the different parent functions, right? So you want to have all of them memorized.
So h can only be in parentheses and a is before the x.
Mm-hmm. Okay, yes. Good, Tice. We're moving down 4. So now for my parent graph, Do you guys want me to sketch the parent graph so we see? I'll sketch it. We're down 4. Let's do this. 1, 2, 3, 4. 1, 2, 3, 4. And we look something like this. Remember, it's not completely accurate. It's just an idea of what it would look like. But now it's saying take the absolute value of that. When we take the absolute value of it, what happens? Everything turns, like if I take the absolute value of -6. So if y equals the absolute value of -6, what do we get? 6. So y would equal +6. So basically, we're taking everything and making it what? Positive. Well, where is everything negative? Underneath the x-axis, right? Y has to now become positive when we take the absolute value. So what I'm going to do is I'm going to take everything underneath the x-axis, everything where y is negative, and I'm not going to make it disappear. I'm not going to erase it. I have to now make it positive, right? Because we didn't just erase -6 and say, oh, nothing's there. We said the absolute value of -6 is now +6. So now we're taking the absolute value of this bottom half and making it positive. How do we do that? Nico, you know?
You can just make the y, like where the point is on the positive point side.
You got it. So right now, this point is on 0, -4. Well, I need to make it positive. So instead of 0, -4, I'm going to make it 0, +4. So now, what's happening is, for our new graph, it comes down here. We're still positive, right? This whole part of it is positive. Do we agree? Just up until I hit the x-axis. I can't go below it. So what's going to happen? You bounce back up to 4. Yep. Now I have to go, because there's still the rest of my graph, right? Now I have to go back down to here. So my new absolute value looks like the W. That whole bottom part goes away.
Is the green one a parabola or
A parabola. The green one was a parabola. And all these, it shouldn't look like it should be rounded when we come back up. It shouldn't look like these.
So that was what you had me until like that point.
Okay, well, look. Go back to the parabola. Okay, go back to this. So actually, before I made the W. So you were good with making this point positive, right? But aren't these lines also part of the graph that also have to be made positive?
Yeah.
So now we're taking those points and we're making them positive. Taking this line, making it positive.
So you're just drawing a line from like where it hits the x-axis all the way to the point on top.
Mm-hmm.
Okay. So what I did, I erased mine and I just made a new graph.
Oh, okay. Yeah, so you want to look at it and make sure every part of this is now becoming positive. Okay, let me finish writing the rest of the steps. Go back to erase. So step 1 was graph what's in the absolute value line. Step number 2, make anything below the x-axis positive. Final graph should be above the x-axis. Yes.
So this only applies for the y, because what if it's like -3 on the x-axis?
Well, you're allowed to have a negative inside the absolute value, right?
Yeah.
So that's fine. Should we talk about domain and range? Are you guys getting better at this? I can't tell. Are we getting better at identifying the domain and range? We spent a lot of time on this now. Yeah? Good.
Yeah, after you told me not to do the stupid set notation, so I could go with the triple notation.
Okay.
It's a lot easier.
Good. All right, so then if we're all better at this, then it's like nobody to choose from. This class is so small. Is it Stefano or Stefanos?
Stephanos.
Oh, Stephanos. Okay, Stephanos. Tell me, what is the domain here? Left and right. So we're looking furthest left. What's furthest left? Infinity. And then we're looking furthest right. What's furthest right? Infinity. So what's negative infinity to positive infinity? We call that all real numbers. If you wanted to do the infinities, you're perfect with that also. All right, let's talk about range. Kiefer, tell me, what'd you get for the range here?
The bracket 0.
Perfect. In interval notation, it's 0 to infinity. If we wanted to write it in set notation, y such that y is greater than or equal to 0. What's wrong, Maya? You okay?
I don't get it.
You don't get how it's 0 to
Stops at a
infinity?
certain point on the-
So what we're doing is we're looking at our lowest point in the graph. What's our lowest point in the graph? 0. What's the highest point? Arrows. Nico, you good? That always gets you. For some reason, the greater than or equal to 0 always gets you.
Makes sense, 'cause I was wrong.
But why?
Wait, so
What's your lowest point on this graph? Look at your graph, your W. What's the lowest point here?
nothing's really marked, but it looks like it would be like a 1 or a negative 1. Like
But
on the x-axis.
Can
Oh,
we?
we're on the y though.
We're on Y.
Yeah,
Range
right,
is
yeah,
Y.
I see it now.
Right? Our lowest point is here on the x-axis,
Yeah.
which is 0 on the y. And then you look at your highest point. Well, your highest points are arrows, which means infinity. Okay. Let's do this one. Y equals the absolute value of 1 over x, close your absolute value, minus 1. That minus 1 is not in the absolute value. So what this is telling us to do, this is telling us graph this function inside. But then after you graph it, then you take the absolute value, and then after you take the absolute value, guess what you're going to do? Translate it. Then you're going to move it. All right, are we ready for this? No? Okay, so let's just look at y equals 1 over x. Do you guys remember this as the rectangular hyperbola? So the important thing with the rectangular hyperbola are the asymptotes. And remember, there's an asymptote on the y-axis. And there's an asymptote on the x-axis. Because there's no negative, because A is positive, which quadrants are we in? Are we in 2 and 4 or 1 and 3? Because it's positive. Are we 2 and 4 or 1 and 3? 1 and 3, perfect. So this is looking something like that. Do we agree? This is 1 over x. Okay, but now what is it telling us to do with 1 over x? Now it's telling us take the absolute value of it. So now if I'm going to take the absolute value of this, we know everything underneath the x-axis has to become positive. So my first quadrant's good. Is my third quadrant good? No. So I need to take this and I need to make it positive. How am I going to make it positive? flip it up top. That's what we're going to do. We're going to flip it up top. So now this is going to be like that. No more of this. All right, I'm not done. Now we've taken the absolute value of 1 over x. But now they're saying take this and translate it. It's saying take this and translate it 1 unit down. Because remember, our absolute, our format is y equals a times 1 over x minus h plus k. So that one's not with the x. That one's outside of the x. So that means that's the k. And what does the k tell us? Our vertical shift. So now we're going to take this, and our shifting is for the asymptotes. So we're going to now shift the asymptote 1 down. So let me show you our new graph when we do that. So my vertical asymptote stays the same. But now my horizontal asymptote is not on the x-axis anymore. Now it's 1 unit down from the x-axis. And our curves are still in the same spots, just shifted 1 unit down. This is our final answer. All right, what's our domain here? Basically, x could equal every number except for what? X can equal every number except for what? Tice? That's y. Y is -1, right? The x, -1 on x is over here. That's going through it. So this is our x. So we're looking for this, our x